Hi folks, we're going to take a look at a couple of questions from page 106, number 8. Okay, and they're actually pretty similar questions. But let's start with the first one here. So we have to find the derivative of this thing. So one thing we can do, which wouldn't be too hard, would be to square this binomial and then multiply by x cubed. That would actually be reasonable, whereas I would say much less reasonable in 8e. Okay, but I'm going to solve both of these using derivative properties. Okay, so here, the first thing I notice is that I've got this product. So I've got x cubed, and then I got 3x minus 5 all squared. So I'm going to treat this as a product rule problem. Okay, so let's go ahead and do that. So here we have the derivative of the first, which is this 3x squared, times the second function, 3x minus 5 all squared, okay, plus the first function, x cubed, times the derivative of the second function. So in finding the second function, I realize I'm going to have to use a chain rule. Okay, so this is going to be like my u. So derivative of u squared is just 2u. So I'm multiplying this by 2 times 3x minus 5. And then I have to take the derivative of u with respect to x, and the derivative of 3x minus 5 is just 3. Okay, so here's my derivative, but I'll actually simplify this, since this is the type of function that we will likely end up having to simplify. So the idea here is not to multiply everything out, but to look for common factors. And I notice here there's a common factor of 3, so I'll remove that. Okay, I notice it's some x's and some x's. Here there's 2 of them here, 3 of them there. So there's 2 that are in common, so I can factor out an x squared. And even the 3x minus 5's common factor, there's 2 of them here and only 1 of them there, so I can take out the 3x minus 5. Okay, so all of these are common factors which I would have been able to factor out. So let's see what we're left with. Well, we got rid of the 3, we got rid of the x squared, and we got rid of one of these binomial factors. So I'm just left with 3x minus 5 here from the first term. Okay, now let's go to the second term. Well, here we got rid of the 3, but there's still the 2. Okay, and here, well, we got rid of 2 of the x factors out of the 3, so we're only left with 1, and we got rid of the factor of 3x minus 5. So that's it. That's all we're left with. And so now we can simplify out that square bracket. Okay, and let's see what we're left with. 3x plus 2x, so 5x minus 5. And I guess in principle you could factor out the 5 there if you wanted to. Okay, but in the end, why is this simplified? Because it's in factored form. And as much as possible when I'm working with polynomials, when I'm working with rational functions, I'd like to have them in factored form. So this is very nice. Okay, so I'm going to do something very similar in the second one, because again, I recognize this as being first a product of these two functions, x to the fourth times the cube of that binomial. Okay, like I said, in this case here, I wouldn't consider it an option to cube this and then multiply by x to the 4 and take the derivative. It makes more sense to do what I did here. Okay, so let's go ahead. Derivative of the first, 4x cubed, times the second function, 1 minus 4x squared all cubed, plus the first function, x to the fourth. And again, the derivative of this one here is going to require the chain rule. So this is my placeholder variable u. So what do we have? We have the derivative of u cubed is 3u squared, so 3 times 1 minus 4x squared all squared, and then times the derivative of u with respect to x, so that's just going to be negative 8x. Okay, and if I take a look here, I'm going to have lots of common factors. So here I've got a factor of 4, and here I've got a factor of 8, so that contains a factor of 4, so I can take that out. Let's look at these x's here. Well, I've got 3 of them here, and I've got 5 of them there, so in the end I've got 3 common factors of x, so there's my x cubed. And 1 minus 4x squared, well, I've got 3 of them here, 2 of them there, so I've got in common, the ones that are in common are 2 of them. 1 minus 4x squared all squared. Okay, and now let's open up a square bracket to group together what we have left. So we got rid of the 4, we got rid of the x cubed, and we got rid of 2 of these factors. So I'm left with one of these factors, so 1 minus 4x squared. Okay, and for this one here, let's see what we've got. Well, we got rid of the factor of 4, so we're left with a factor of 2 here times 3, and here it's negative, so minus 3 times 2 is 6. Okay, we got rid of both 1 minus 4x squareds here. Okay, took that out as a common factor. So what I'm left with is I had 5 x factors in all. I took away 3, so I'm just left with 2. So minus, so there you go, 6x squared. And now I can simplify what's left in the square bracket. So 4x cubed, 1 minus 4x squared, squared. And here we're left with 1 negative 4 minus 6 minus 10x squared. And that's as far as I can go. Okay, so just to recap, number 1, notice these are product rule questions. Number 2, careful that in both cases the second function needed the chain rule to solve. And then from there, once you take your initial derivative, look for lots of